Alright, we're coming back the second half. I apologize because my mother and sister were trying to FaceTime me during that and caused some craziness and it shut my entire phone off. But, allow us to back up and start this problem over once more. So what I was saying is when we're dividing our polynomial, you're going to want to make sure that you can find something that is going to be able to help you eliminate portions of it to see if this is going to be a function of your polynomial. So what I mentioned prior before the video shut off was x1. We're going to multiply all this by x1, okay? And by doing so, it's going to allow us to eliminate portions of this equation. So this is going to give us x3. We're going to have 1x to the second and negative 2. And like I said, I have, I'll also send you guys a copy of my workout sheet here that I did it on. That way it's a little easier for you guys to see. And we've done this before. We've used substitution and elimination. So we're going to use elimination this go around. And by doing so, we're going to multiply by negative 1 here. The whole bottom. So that means this is going to become negative, this is going to become negative, and since the 2 was already negative, what do you guys think it's going to be? It's probably going to become what? Probably positive. Alright, so by doing so, we've eliminated what? Our x to the third. So we're going to rewrite what we have now and start the problem all over. So what I'm saying is we have bringing this down should be positive 3x to the second. I've lost the number here. 2 and x, that's 3x, because this was an x because we multiplied it. And then we have our negative 6. Okay. So I'm going to flip over to another page, that way we can see. So this right here we eliminated to get the second half of our equation. So we're going to take our x2 plus x minus 2. And remember, we already got x to the first. We're rewriting what we just found, which was 3x to the second plus 3x minus 6. We want to do the exact same thing. We want to find something that we can multiply by in order to get rid of our equation. So, this time, what's going to give us a 3x? Probably going to have to multiply by what number? 3. And by doing so, that goes to here, here, and here. So when I rewrite that, that gives me 3x to the second, 3x to the first, and what? And 6, right? Negative 6. Well, guess what? I need to be able to do what? Eliminate. So, I'm going to go ahead and multiply by negative 1. That means this becomes negative. This becomes negative. This is already negative, so it becomes positive. So, when I add them together, I get 0. Add negative 3, positive 3, 0. Negative 6, positive 6, 0. So, is this going to be a function of the equation x plus 3? Yes, because all of our remainders were what? 0. So, our answer is x plus 3. Because it gave us remainders of 0. I'll let you guys try example 3. It's the exact same format. How do you know if it's wrong? Like, how do you know if it isn't going to be a function? Because when you do this problem, and if it gives you a remainder, then no, it is not going to be a factor. It has to come out with no remainder in order for it to be a factor. I repeat, no remainder to equal a factor. Now you can look back here that we just did a moment ago. All this came down to 0. So yes, it was a factor. And even if you're just looking at number 2, just for quick reference, if we were to go ahead and solve it, doing it the exact same way that we did this problem here, you can see that it actually has a remainder. So example 3 would not be a factor, okay? Flip on over to the next portion, if you would, on and look at example 4. I actually love doing these. Synthetic division is quite fun, I think. Call me crazy. It's pretty simple. It can be a little overwhelming at first, but as long as you're paying attention, and I promise it's not that bad. Okay. So if we're given the problem, and it says we're dividing by our polynomial, so we're going to go into 3x to the third minus 8x plus 14. And all this is going to be divided by what? X minus 2. Looks similar to what we did before, but this is just going to be another method of solving. So what we're going to do is we're going to formulate it just a little bit different. We're going to pull this 2 out right here, okay? And it's going to be our main dividend. So we're going to take 2, you're going to put it in a square like that, and that means it's going to go into your entire problem. You're going to lose the variables, okay? And when I say lose the variables, I mean that we're going to rewrite it like this. So 3, we have negative 8, we have, and when you want to read this, it's 3x to the first, and this should be 8x to the second. There's no x to the first, okay? There's no x to the first, but there is a 14. So you're still kind of reading it like ax, bx, and c, but here we're going to take 0 since there's no x to the first, and 14, okay? We're going to set us up kind of a little table here, and we're going to bring down our first number. And when I say our first number, that means you're going to bring this down right here, the 3, okay? You're going to take the 2 and you're going to multiply it times 3. So this 2 times 3. What does 2 times 3 give us? 6. 6 goes back right here. And I'm actually going to change color, that way you guys can see everything I'm putting in. So 2 times 3 gives us 6. What is negative 8 plus, is it negative, do I have negative 8? Yeah, negative 8 plus 6, negative 2, right? So then I take this 2 times negative 2, and what do I get? I should get negative 4. Negative 4 plus 0 gives me what? Negative 4 plus 0 just gives me negative 4. Okay? And for my last portion, I'll bring this over here. 2 times negative 4 is what? It's negative 8. And negative 8 minus 14 is 6. Okay? And 6 is going to be our remainder. And so when I go to rewrite this problem, I no longer have x to the third. I have to start by writing x to the second. So I have 3x to the second, and all these numbers are coming from right here, the very bottom. Negative 2x to the first, negative 4, with a remainder 6. So we had brought the 2 was our main number we divided by. We lost all of our what? Our variables in order to do this equation. And let's go ahead and take a look at example 5 in this exact same method. Alright, so this time we have x to the third minus 7x plus 6, and we're dividing by x plus 3. What number are we going to start with, guys? We're going to start with the 3 because that's what we're dividing in. And we're losing what? We're getting rid of all of our variables. So we're taking 3, put it in our box, and bringing down all of our numbers. So we have a 1x to the third. There's no what? X to the second here, so we have to put a 0. There's an x to the first, it's negative 7, and there's a 6. Okay? What number am I bringing down first? I want to bring down my 1. Okay? And I'm going to put this back in a different color, that way you guys can see. 3 times 1 gives me what? And this is actually, was it negative 3 they were dividing by? Oh yeah, we're using negative 3 because it said that we're placing the negative 3. So that was my bad. I apologize about that. So this actually should be negative 3. And the reason we're doing so is because it asked us, it said that we're placing the negative 3 from the divisor because we're listing this as a coefficient. So since we have negative 3, we take negative 3 times 1, and what does that give us? Negative 3. We add these together, what does that give us? That gives us negative 3. Negative 3 times negative 3 is a positive what? Positive 9. Positive 9 plus a 7 gives us what? Positive 2. Alright? Bringing the 3 back over. Negative 3 times 2 gives us what? Negative 6. When you add negative 6, you get 0. So we have, I want to put this in a different color, x to the second, x to the first are constant, no remainder. So when we write that, we write it like this. 1x to the second minus 3x to the first plus 2. And again, we're using these as the coefficients because we completed using our divisor and it was x minus. Alright, so we had x minus 3 since we're doing moving it to the left. Our other one started on the left, so that's the reason it became positive. And what I'm saying is, if we had, like the first one was x minus 2, so we moved it to the left and it became positive 2. This one was x plus 3, we moved it over and it became negative 3. So again, from example 4, it was x minus 2. We moved it over, it became positive 2 to start off. This one said x plus 3. We moved it over, and it became negative 3 as our divisor. Alright, well that takes care of what we have for this equation. And again, if you guys have any questions about anything, feel free to shoot me a text. We can do a video conference, no problem whatsoever. Your homework and stuff will be posted online, and I think you guys should have got your packets. And I'll also be taking photos and sending to you of some of the problems I've worked out. So, if you, like I said, if you guys have any problems, feel free to get in touch with me. I'll talk to you guys later.